So, hi guys, welcome to Concept Mastering. Today, will be our topic is actually the vectorial form of Coulomb's law. So, we'll be solving an example and the question on that particular topic. Now, this is a question here. It says two charges, 15 microcoulomb and minus 21 microcoulomb, are 85 centimeters apart. If a touch charge, 65 microcoulomb, is placed midway between both charges, find the resultant force on the 15 microcoulomb charge. Now, the first thing to do in this kind of question is just to represent it the way it is in the question. Just try to do some diagram to represent it. They say that two charges, 15 microcoulomb and minus 21 microcoulomb, are 85 centimeters apart. It means that this one, they are apart. It means this, the first one here is, let's take this our Q1, is 15 micro charge is here, and this one is minus 21 micro charge here, which is our Q2, the second charge. Say that 85 centimeters apart. That means this 85 here is at the middle. 85 centimeters apart. Now, they now said if a touch charge, 65 micro charge, is placed midway means at the middle. The touch charge is here actually 65 microcoulomb. This is our Q3. Now, you say you should find the resultant force on 15 microcoulomb charge. The resultant force on this. Now, if this is 85 centimeters, that means from here to here will be half of this 85 centimeters. From here to here also will be half of this 85 centimeters. That's what you mean actually. So if you divide this 85 into 2, you're going to get 42.5 centimeters here. That is 42.5 centimeters. If you divide this from here to here is 42.5 centimeters. And for here to here is also 42.5 centimeters. Now, in Coulomb's law, we don't do with centimeter, we use meter. We don't do with centimeter, we use meter. So 42 centimeter 0.5, this centimeter, divided by 100. Want to convert to meter, we are going to have equals to 0.425 meter. 0.425 meter. If you want to convert centimeter to meter, divide by 100, you have 0.425 meters. Now, that means this is our 15 microcoulomb, and this is our charge 1. We have our 65 at the middle, and this is our charge 3. And we have our minus 21 microcoulomb, and this is our charge 2. So it means that from here to here, this is the middle. From here to here is actually 0.425 meter, and from here to here is also 0.425 meters. Now, we proceed. I told you guys that our Q1 here, our Q1 is actually this 15 microfarad. So 15 microcoulomb, not farad though, that's just coulomb. Which is actually equals to 15 times 10 raised to the power minus 6 coulomb. Our charge 2 is actually equals to minus 21 microcoulomb, which is equals to minus 21 times 10 raised to the power minus 6 coulomb. Our third charge is actually equals to 65 microcoulomb, which will actually give you 65 times 10 raised to the power minus 6 coulomb. So these are the steps by step we're going to follow when solving this kind of question. Now, they say we should find the resultant force. What are we finding? The resultant force. The resultant force on Q1. Which one is Q1? The 15 microcoulomb. Now, if you want to find the resultant force on Q1, it's actually going to give you the resultant force on Q1, which will give you actually the resultant force on 1 and 2 plus the resultant force on 1 and 3. So this is actually the resultant force of 1 and 2 plus the resultant force on 1 and 3. Now, in the last class, I also in the previous video, I explained this in details. You may just go back and watch it again in my previous video. Now, first of all, you're going to get the resultant force on 1 and 2. The resultant force on charge 1 and 2. That is this was meant actually. So the resultant force on charge 1 and 2. Let's just find this one first here. Resultant force on 1 and 2 will be equals to K times Q1 and Q2 all over your magnitude, which is your R1 and 2 all squared, times your unit vector, which is 1 and 2. Yeah. So the very first thing you're going to do is to find your unit vector. You'll find your unit vector. And your unit vector, to get your unit vector is actually unit vector of 1 and 2 is actually the position vector. The position vector 1 and 2 divided by the magnitude This is your position vector. And this is your magnitude. This is actually your magnitude of the position vector. The magnitude of the position vector. Now, you first get your position vector. How do you get your position vector? The position vector is actually position vector 1 and 2. That is the distance between 1 and 2 is actually R1 minus R2. Now, you are finding the distance from charge 1 to charge 2. Like you want to get the distance actually, that is the position. You want to get the position actually. Now, listen attentively. From Cartesian coordinates, our Cartesian coordinates, we have this. Yes, we have this. We have our x-axis, which is here is plus. You have our x-axis, so here is minus. You have our y-axis, here is plus. We also have our y here, which is minus. Now, in Cartesian coordinates, we say here is the positive side and here is the negative side. Let's take here as our I. And let's take here as our j. So we'll be using I and j, not x and y. We're using I and j. Now, I intentionally curve my I to the right. Why? Because some people write I like this and also write j like this. you can see both of them are both the same. You don't even know the difference. So just to avoid confusion, just write intentionally curve your I to the right and your J curve it the way it's supposed to curve to avoid any confusion. Now listen attentively. We are finding the position vector here. We are finding the position vector. That the position where R1 and 2 is. Now, in this very first one, this is the position. Let's first the first one, the R1 first, the position vector of R1. Now, your R1 is always 0 because R1 is your 15 microfarad, your 15 microcoulomb, because that's where your first, there is the starting point. This is the starting point. This is your origin. You have not yet moved. There's no distance here. You are just starting, like you are still on the starting point. You have not yet moved. So here is actually your 0. Now, if we want to find the distance, let's find the distance of our arrow to here. Our arrow to. So come in, let me check something. Okay, I'm with you guys. Sorry, there's a mistake somewhere. This is our second, here is our second charge here. Here is the second charge. Here's the second charge. Here's the second charge. This is our second charge. And this is our third charge. Please note that it was a mistake at the initial. This is our second charge and this is our third charge. So here this one is the second charge. It is the second charge and this one is the third one. So please correct the mistake, please. Correct the mistake. Sorry for the mistake. Now it's our second charge and this is our third charge. So now, from here now, you notice something. We are still on our origin here. Our origin, our R1 is always 0 because this is our starting point. Actually, like I told you guys earlier. Now, we want to find the distance to R2. If you move from here now, if you move from here to here, the distance is actually 0.425 meters. The distance is 0.425 meters. In our Cartesian coordinates, if you are moving to the right, this is the arrow here. You can see this arrow pointing like this. If you are moving to the right like this, it means the positive. You are moving to the positive side. You are moving to the positive side because I can see here, you are actually moving from charge 1 to charge 2 at this point. And if you're moving from charge 1 to charge 2, it's actually you're moving to the right. And like our Cartesian coordinates, if you're moving to the right, you can see the arrow pointing. When you're moving to the right, it's actually a positive. The positive position. The positive side. You're moving to the positive side, which is actually X. Now, and I told you guys, like from here to here is actually 0.425 meters. So what are you going to have? You have here, you have minus, this minus here, then plus, because we're moving to the positive side, plus 0.425 meters. 0.525 meters. I, you put your I. That's the position of the vector. Now, what are you going to get from this now? Your position vector. This is actually r. Forget it's big like this. It's actually r. What are you going to have? You have your r1 and 2 will be equals to minus times plus is going to give you minus. You have minus 0.425 meters I. 0.425 meters I. Now we are going to find the magnitude of the position. The magnitude. The magnitude of this. The magnitude of this will give us R1 and 2. R1 and 2. The magnitude R1 and 2 be equals to, it will be the square root of this. That is, we have minus 0.425 meters squared, then the square root. If you want to find the magnitude of any something, it's always the square root of that. So now, if you square this, you first of all square this first. What are you going to have? You have your R1 and 2 will give you the magnitude, give you the square root of 0.0018 0625. Now, if you now find the square root of this, you have your R1 and 2 will now give you 0.425 meters. 0.425 meters. Now listen. There's something in mathematics I want to tell you guys. Just in maths, when you have a square root and square, you simply just cancel this one. This one will cancel square, and you're going to still get the figure in here. It does not matter. It does not matter what's what's it called, symbol means carry, whether it's carry minus or it's carrying plus. We should still give you that the same answer. Let me give you for instance now. I'm having minus 3 squared. If I'm having minus 3 squared, what does this mean? It means that minus 3 times minus 3 bracket squared, minus 3 times minus 3, this is minus 3, is going to give you 9. Now the square root of 9 is going to give you 3. You see it? It doesn't matter where, if minus is 0 or plus 0. Once you are seeing square here and you are seeing square root will cancel, square will cancel square root, and this sign will also vanish, and we'll do, the answer is going to give you that the same figure that was there. So these are those tricks when you are solving questions, especially if you are doing a CBT exam. You don't even need to press your calculator or be used to can press this. Once you get to this position and you're seeing 2 and you're seeing your square root and you're seeing minus, this square root will just cancel, this square is cancel your square root, and your minus is going to vanish. It's going to vanish too. You're going to have this particular answer. This, you're going to have the figure that you are trying to multiply or do the square root, which is this one. You can see they are still the same again. I give you instance here. You see minus 3. I see did it minus 3 times minus 3. I expand my brackets. It give me 9. I do the square root of 9. It still gave me 3. So if you are doing solving questions in your exam, once you get to this position, you are seeing square and square root, and I still see minus, even though it's plus, it won't affect it. It will still give you that the same number here. That same number that you're finding the square root and the square. So take note of that. Take notes. Because in exam you're doing with time. You don't have time. So still on this page. Now we have gotten our position vector and our magnitude. Now we are going to find our unit vector. Now from our unit vector, I told you that our unit vector 1 and 2, this is unit vector 1 and 2, is actually the position vector. The position vector. Sorry. Position vector, which is R1 and 2 divided by your magnitude. The magnitude of the position vector. The magnitude of the position vector, which is actually R1 and 2. Now, in this here, this is what we got our position vector. What do we get our position vector here? Look at it in here. This is what we got our position vector. This is what we got here. We got minus 0.425 meters I. That's what we get. So we are going to put here minus 0.425 meters I divided by our magnitude. What do we get our magnitude? We got 0.425 meters. 0.425 meters. 0.425 meters. Now, 0.425 meters, we cancel this one, we cancel this one here. We are left it. That means our unit vector will give you minus I. Will give you minus I. Now, I still proceed. We have gotten our unit vector and we have gotten our magnitude also. At this point, we don't plug in all our parameters now. Now you say to find the force of 1 or 2, we use this, our K equals to Q1 and Q2 divided by our R1 and 2 all squared. This is our magnitude times our unit vector 1 and 2. Now listen attentively. Listen attentively. You have our force 1 and 2. Already we know our K. Our K is actually 9 times 10 raised to the power minus 9. What is the charge 1? I told you guys charge 1. Our charge 1 is actually our 15 microcoulomb. 15 microcoulomb. That will be equals to 15 times 10 raised to the power minus 6. Now, our second charge, I told you guys, I corrected you guys, our second charge is actually 65 microcoulomb. Our second charge is 65 microcoulomb. That is 65 times 10 raised to the power minus 6 divided by our magnitude. I already told you guys this is our magnitude. And what do we get our magnitude here? We got this is our magnitude here, this one here. We got 0.425 meters. 0.425 meters. So you just put 0.425. Don't need to put the meters here. You can see at this point here, there's a square here. So you're going to square it times your I, your unit vector. This one here, your unit vector. What do we got our unit vector? You got minus I, then times minus I. Times minus I. Now, we proceed. Our force 1 and 2 will give us, when you times your denominator, it times everything, you're going to have 8.775 divided by 0.180625 times minus I times minus I minus I. Now, when you do that, what you're going to have is your force 1 and 2. Force 1 and 2 will give you 48. When you divide this by this, we give you 48.58 times minus I times minus I. Therefore, your force 1 and 2, the force on charge 1 and 2 will now give you minus 48 0.58 Newton I. So this is the force charge on 1 and 2. This is the force on 1, this to 2, force 1 and 2 charge. The force on 1 and 2, this is what we got. Now let's go the force 1 and 3. We still use the same method. What we did. We are getting, let's get the force 1 and 3. We are getting, this one is force 1 and 3. We still use the same formula. Our K is equals to Q1 and Q2 divided by our magnitude, which is R1 and 3. No, this is not Q2, this is 3. This charge 3 actually. So this R1 and 3 all squared times our R unit vector 1 and 3. You can see you are finding the force charge on 1 and 3. That will be Q1 and 3 divided by your magnitude R1 and 3. This is your magnitude times your unit vector R1 and 3. I told you guys the first thing is to find your unit vector. And what is your unit vector? It's actually the position divided by your magnitude. This is what I told you guys. Your unit vector is actually your position divided by your magnitude. Now let's first find our position first for this particular one now. Let's find our position now. Our position vector R1 and 3 will give us the position of R1 minus the position of R3. Now, I told you guys earlier that the R1 is always 0 because it is your starting position. You are staying, it's just like you want to move for one place, but you have not yet moved. You are still standing at that position at that time, you have not yet moved. So, R1 is our 15 microcoulomb. Let me show you guys. This is it here. R1 is our 15 microcoulomb. So here we have no way to move. You are still standing here. At this point is actually 0. So you put 0 here. Minus. Now you want to move from here to here. This is our charge 3 here. We want to move from here to here. Now, from here to here. Now, the distance from here first to here is 0.425 meters. Now, if you are not moving from here to here again, it's also another 0.425 meters. What does it mean? That means if you want to go from here, you simply plus these two distances together. You plus 0.25 plus 0.25. That will give you 0.85 here. That will give you 0.85. That's the distance. And what do you notice? You notice that we are moving from our left to our right. We are moving from our left, from here to here. And in our Cartesian coordinates, I told you guys that if you are moving from here to here like this, that means you are moving to the positive side. You can see the positive sign here. You're moving to the positive sign. That means what our R3 is going to be there? It's going to give you bracket plus 0.85 close bracket. So that's what we're going to have. When this minus multiply plus, we are going to have minus. That means our R1 and 3 will give you minus 0.85. This is actually meters I told you put your meters. So now we proceed. The next we are going to find is we are going to find our unit vector. So our unit vector is actually the R1 and 3. Our magnitude, we find our magnitude. So it's not our magnitude we are going to find our magnitude. These are how to find our magnitude. Because for us to get our unit vector, For us to get our unit vector, this one here, you first find the position, then divide it by our magnitude, the magnitude of the position vector. Now, I proceed. This is our magnitude. Let us find our magnitude. I told you guys earlier, if you want to find your magnitude, it's going to be, you want to find the magnitude of this position vector, it will be minus, put your bracket first, minus 0.085, sorry, it will be minus 0.85 close bracket squared, then put your square root. I explained this thing in the previous one that when you see this kind of question, you don't even need to use any calculator. As far as you're seeing square and you're seeing square root, and also seeing minus, first the minus will just vanish, then this square will cancel this square root. It's just simple mathematics, just simple logic. No need of you doing the square root of 0.825. After doing it, you now come and do the square root again. You're just wasting time. An exam is about timing. You may know it, but you end up spending, question that you're supposed to just spend 1 minute, you end up spending like 15 to 20 minutes. And that time your time have already gone. Exam is about smart. It's not about how smart you are. How smart you are. So in this kind of thing, you just work very smart. Square will cancel square root, and this minus will vanish. Right? What you have left is 0.85. If you even do it to your calculator, you still get the 0.85. You still get the 0.85. So therefore, our unit vector will give us, our unit vector 1 and 3 will give us 0.85 meters. Now let's find the position vector. Let's find the position and the unit vector. Actually, you're finding the unit vector at this point now. You're finding the unit vector. Our unit vector, arrow 1 and 3, will be equals to the position vector. What do we get our position vector? We got minus 0.85 meters high, divided by our magnitude, the magnitude of the position vector. What do we get as the magnitude? We got 0.85 meters. I always differentiate everything. Know when you are doing unit vector, this one I see here represent magnitude. Why this one here represent the position? Why this one here represent your unit vector? Position, magnitude, unit vector. So if you want to get your unit vector, you divide your position vector over your magnitude, and what we got as magnitude is 0.85. So divided by 0.85. What do you observe? You have 0.85 meters here. This one here will cancel this one. Therefore, your unit vector will be equals to 1 minus 3. So unit vector 1 3 will be equals to minus I. Your unit vector 1 and 3 will be equals to minus I. Just listen attentively. Listen attentively. Now, the next thing is to find. Let's find the force now. Let's put in all our parameters. All our parameters. Now we have force 1 and 3. Now, the first thing is K. What is K? The value of K. Let me just give you guys K, Q1 and Q3 all over R1 and 3 all squared, then times your unit vector 1 and 3. Now, what is your K here? Your K is actually 9 times 10 raised to power 9. What is our Q1? Our Q1 is actually 15 times 10 raised to power minus 6. What's our Q3? Our Q3 here is actually minus 21 times 10 raised to power minus 6 divided by, what did we get our magnitude? This is our magnitude here. We got 0.85 meters. 0.85 5 meters. Now it is squared here. It is squared here, so you're going to square it also. Times our position vector. What is our position vector? Our unit vector rather, not position. What do we got our position vector? This is it here. This is r1. Sorry, what do you get there? Position vector, we got minus I. Minus I, don't put your minus I here. You can bracket it. This is actually, this thing is actually unit vector. This is just 1 and 3. Forget it's actually big. It's supposed to be small. Let me write it for you guys again. Your arrow 1 and 3 equals to minus I. So this is it. So just listen attentively. Just listen attentively. When you divide this, when you multiply all this, the numerator, you're going to have, let me turn to the next page. I'm coming. Okay, yes. No, still on here. When you multiply the numerator, you will have, what we're going to have there is your f1 and 3 will give you minus 2.835 divided by, when you square this 0.85 squared, you have 0.7225, then times your unit vector, which is minus I. So first of all, you divide this minus 2.835 over 0.7225, you get your force 1 and 3 will now be minus 3.924 Newton, bracket minus I. Then your force, this is what you're going to get. So this is what you get. When you divide this by this, you get this. So now we have minus 3.924 Newton. This minus here will times this minus. Minus times minus will give you plus. That means our force 1 and 3 will give you 3.924 Newton I. I told you guys I intentionally curved my I to the left so that to differentiate it from J. Now the next thing is to find the resultants. At the beginning I told you guys your F, the resultants of force 1 will be equals to the force on 1 and 2 plus the force on 1 and 3. Now what do we get at force 1 and 2? What do we got as force 1 and 2? Let me show you guys. Yeah, in force 1 and 2, this is what we got here. In force 1 and 2, this is it. We got force 1 and 2, we got minus 48.58 for minus 48.58 Newton I. That means the resultant force 1 and the resultant force on force 1 will give you, this one is going to give you minus 48 point minus what, sorry, resultant force or 1 will give you minus 48.58 minus 48.58 Newton I, close your brackets, plus, what do we get as our force 1 and 3? This is what we got our force 1 and 3. This is what we got, sorry, this is what we got here. That is going to give plus 3.924 Newton I. We do minus 48 plus 58 and plus 3.124. What you're going to get, you will have your force 1, the resultant force on 1, the resultant force on 1 will now give you minus 44.656 Newton I. When you do minus 48.58 plus 3.924, this is what you're going to get. And here is our final answer. This is our final answer. So I'll also be sending more questions and show you the easiest way. In our next topic, I will show you the trick. I will show you the trick so that we can go all this stress in your exam. I will show you the tricks we're going to use and the shortest cut in our next video. Thank you very much for watching. If you like this video, comment on your questions. If you have any questions at all, comment it in your comment section. Click on the subscribe button and share and like my videos. Thank you very much for watching. Have a wonderful day.